Hey friends, hope this finds you well. This is a quick video to finish up some examples I didn't finish in class because I spent some time going over the exam. Okay, so the problems that we're dealing with are all finding the area between two curves. So it's always going to be top minus bottom or right minus left. Okay. The only real trickery is what if the two that are top and bottom switch places. So because of that, you often have to look at a graph and see where the intersections are. Okay, so let me jump to exercise 6 on the iPad, and naturally it tells me that it has to download and install something first. Oh, but it was quick, so that was great. All right, so this one we're looking at here asks us to find the area enclosed by e to the x, e to the minus x, and y equals 2. So I feel like there wasn't enough details written on that. Let's take a quick look at something where we can graph this. And I feel like I want to try to use the GeoGebra graphing calculator as opposed to using Desmos, just because it's got a nice, what is it? A nice copy and paste feature. So I'm going to say e to the x and hit enter on that, and then y equals e to the minus x, and hit enter on that. Oh, and then the last one was y equals 2. I see what's going on there. All right, so if you notice on what I just graphed, I've got that kind of, it's not quite a triangular region, but it's almost a triangular region. So I'm going to try to adjust this a little bit where that's more or less centered. Come on. Okay, and then I have to remember how to do this anew every time. So it's over here. I want to export the image, and okay, I will. Okay. I'll copy to GoodNotes. That's not really what I want to do. I'm sorry, my actions are not showing me what I need on this. So, exam mode settings. I apologize for having this bit in here, but it is really just a matter of export image is not taking me to the place that it normally takes me to. Maybe. Okay, I will just press export image and just do what it says. It's not what I want. So I don't want an airdrop. I just want a copy of it. Okay. Well, that's weird. Okay, the controls changed. I mean, all right. So then with respect to this, come on. I want to try to color that in so that it's a little bit more obvious that we're talking about this region here. Okay. And so once we know that we're talking about that region there, you have a couple of different ways that you can go at this. Either you can talk about having vertical slices here and break the region into two pieces, or you can talk about having horizontal slices here and have the region as just one piece. Either way that you go at it is going to be about the same amount of work. The problem that I see is that if we do it with the horizontal slices, we're going to have to solve for x, and that's going to involve a logarithm. And the integration trick for logarithms is something we haven't quite hit yet. So we're going to go ahead and split this region into the two parts, the left and the right. And of course, we can see that we have an intersection here at 0. But then this up here, you've got to have your y being 2 and your y also being e to the x. So that means that we're going to end up with a negative ln2 and a positive ln2, okay? And then in between, we are thinking about having our slices be vertical. So you will integrate from negative log 2 up to 0, and your top is going to be the 2, and your bottom is this e to the minus x dx. And then you're going to integrate 0 to ln2. It's going to be 2 minus e to the positive x dx. Okay. Now it's going to turn out that you get the same number out of both of these. But I don't want y'all to get into too much of a habit of jumping to the conclusion you have symmetry. But the main thing that we'll have to do in this is just going to be repetitious. You know what? Never mind. I'm going to go ahead and do the integration by hand on this. Or I'm going to do the integration explicitly with each piece, because you'll need to see that when we integrate this e to the minus x, then you're going to have to divide out a -1, but you already had a -1. So this will turn into plus e to the minus x, negative log 2 up to 0. And then on the other one, it'll be 2x minus, and it's just a plain e to the x. And we go from 0 to ln2. And really the rest of this problem is going to be doing arithmetic stuff. So you plug in the 0, you have 0 plus 1 minus 2 times negative ln2 plus e to the minus ln2. Okay, and then plus, now we plug in the ln2 first, and we have 2 ln2 minus e to the ln2, then minus, and now we plug in 0, and you have 0 minus 1. So simplifying, we would have 1 plus 2 log 2 plus, no, sorry, minus e to the ln2 is just 2, and then plus 2 ln2, and minus e to the ln2, well, that would just be 2, and then minus a -1. All right, so that's going to end us with a 4 ln2, collecting the logs together. And let's see, 2 plus 1s and 2 minus 2s. So 4 log 2, I'm going to put superfluous parentheses there, and minus 2. And I believe that's what we ended up with. Yeah, that's what I ended up with when I did it the other way. All right. So hopefully all are good with that. And let's take a look at exercise 7. Again, you should pause these things and try them on your own, but there's no reason for me to put a pause in the video. All right, so this one here, we're looking at the area enclosed by these three things. So I think that, like before, I'm going to go over here to my graphing utility, and I'm just going to delete the stuff that was there already and put in a new one. And I need to graph log x over x. So I'm going to put a division sign first and put ln x at the top and then x at the bottom. I'll just tell it to graph from there. And then y equals 0. So I'll go ahead and say y equals 0 explicitly because that might be handy. And then I'll say x equals e. I hope it understands that. All right. So I need to hide my keyboard. Okay, don't need that. How do I don't remember how to, oh, there, I had my keyboard by touching off the keyboard. All right, so looks as though the pieces need a little bit of shrinking this way. Aha. And then maybe that way. All right. So now I think y'all can see what it is that we have going on there, that we've got that kind of a lumpy triangular region there that's above the x-axis. And now I'm going to go do the export image again and just tell it to copy. And then, okay, I'm gonna paste that. And I am going to do a little bit of cropping here. And sorry if that's kind of boring to watch, but it doesn't actually show on your screen the crop that I'm doing. So tell it I'm done and make it a little bit larger. That may turn out to be a bad move, but yeah. All right, so then I'm going to go ahead and shade in the region so that it's a little bit more clear. What it is that we're doing here. And there, good enough. All right. So that's the region that we're looking at here. And it seems as though the most convenient way to tackle this is going to be with our vertical slices. So we're going to have to know about the x value there and there. So we have an integral from 1 to e. And it looks like it's just going to be log x over x and then minus 0 dx. Probably should have put another curve in there, so this was a little bit less boring. But the trick on this is that when you integrate a logarithm, that you frequently need to then do a du of being 1 over x dx. Okay. And so that will turn this integral that we've got into just u du. When x is equal to 1, the u is going to be log of 1, which is 0. And when the x is equal to e, the u is going to be the log of e, which is just 1. So this turns into 1/2 u squared. Evaluate 0 to 1. 1/2 times 1 minus the 0. So we end up with a 1/2 out of that, which is not what I got before. But yeah, so being that I am a little bit trepidatious about, did I integrate that wrong? I'm going to jump over here to my graphing calculator and just have it do it for me. So I have to type in here integral, and it should auto-complete that, but it didn't. That was weird. Okay. But I'm going to say then parentheses and the F that we've got there. So I guess I need to type in F and then a comma. We're going from 1 to E. And we got 1/2 out of it. Okay, so I checked my work like that. And so this answer of 1/2 is correct. And there's a typo once again in a handout. So sorry about that. All right, last one. And again, stop and stuff. But this one has very similar things, a log x and a log x squared, both over x. So let's see what that looks like in the graph, because I don't know about y'all, but I'm not super good at visualizing some of these things. So I'm going to go ahead and have the division again, parentheses on top, and an ln x in there. And then I have to go outside the parentheses, but not outside my fraction. Wow, this is annoying. And square it. And down below, I've got the x. All right, so now with my graph there, y'all can see that we've got that region. I don't know, it's vaguely moon-shaped or something that we're getting there. So then I'm going to go ahead and do the same things before. Export an image, tell it to copy. I guess, you know, I've been saying that I didn't like that they changed the controls there, but I'm thinking now maybe I do. It seems like the control is a little bit more sensible, you know? It kind of does the same things as when I copy across other applications. So, all right. And just like before, I'm going to do the little OCD thing of trying to color this in without going over the lines too badly. So, all right. So that gets us an idea of what it is we're looking at here. And you might not be able to spot that super easily, but when we let the x be equal to e, then we'll get a 1 on the top of both of those functions and an e on the bottom. So that's what's going on with that. All right, so we are going to integrate from 1 to e, and we're thinking about our vertical slices here. And the vertical slices, the top of them is the log x over x, and the bottom is the log x quantity squared over x dx. Nicely, you can factor out the 1 over x to the end of that and have your dx over x. And we're going to do the same u substitution as before. And so we are integrating u minus u squared du. When our x is 1, then our u will turn out to be 0. When our x is e, our u will turn out to be 1. So, man, this is actually pretty neat. 1/2 u squared minus 1/3 u cubed. Evaluate 0 to 1. Plug the 1 in. And plug the 0 in. And we end up with 1/6 for the answer there. All right. So hopefully that felt pretty natural to y'all. Sorry that we didn't quite finish those during class time, but yeah. All right. I will see you all Friday.